Hello everyone, I am Rekha Murthy, Assistant Professor from Department of Electrical and Electronics Engineering from Sai Vidya Institute of Technology. Today I am here to explain the experiment related with the cycle 2 of Electrical Machine Laboratory 1. So the experiment is the voltage regulation of an alternator by ZPF method. So in the previous sessions, we have discussed about the voltage regulation of an alternator by EMF and MMF method. So here the concept of determining the voltage regulation of an alternator is almost similar. The thing is we have changed with the methods, different methods. So ZPF is a zero power factor method. So in this method, it is mainly based on the separation of the armature leakage reactance and armature reaction effect. So in the operation of an alternator, the armature resistance drop and the armature leakage reactance drop, they are actually the EMF quantities, when the armature reaction is basically the MMF quantity. So the armature leakage reactance is called to be as a Portier reactance in this method. So this method, that is why it is called as Portier reactance method. So to determine the armature leakage reactance and the armature reaction MMF separately, so two tests are performed on this alternator. So the two tests are open circuit test and the zero power factor test. So here also we are going to consider the same setup. So that is why we are going to make use of almost the similar equipment. The difference here is since it is a zero power factor test means there will be a very low power factor. So we require one watt meter. That watt meter which is of low power factor. Instead of using a 2 ammeters, we have to make use of a 2 watt meters which is of the range of 0 to 10 amperes, because the alternator rated current, as we have seen in the nameplate reading in the previous session, it is of 16 amps. So we have to prefer the 10 amperes, and the voltage obviously it is a 3-phase, so we require the 0 to 600 volts. And the other components will also all remain as it is. So this is what the setup. So only the difference here, what you can see the change here, we are making use of a 2 watt meter. So it is almost looking like a 2 watt meter method. And the current, the armature is required in one of this line, that is V phase. So therefore on the V connection, we have to make use of it. And on the other side, we are going to make use of an inductive load because it is a LPF. So therefore we should not use a resistive load. So we have to make use of a inductive load. So this is a representation of an inductive load. Okay. So now let us see the connections, and these are the equipments which you can observe, all of you. These are the two LPF wattmeters which you require, and TPST switch is there, and rheostat, and the same setup we have to make use of it. In addition to that, one inductive load. This is also, they will be having a 3 terminals, and these 3 terminals need to be connected in a delta fashion. So let us see that what are the connections. The positive supply should be connected to the line, and F should be connected to the rheostat. The other end of the rheostat should be connected to the Z, and the Z is coming back to the negative supply. And similarly, the armature should be connected to the A, and the other end of this AA terminal should be connected back to the negative supply. This completes the motor part of it. And coming to the alternator, the TPST, one end of this should be connected to the U and V and W. Similarly, the output of this U should be connected, output of the TPST should be connected to the wattmeter M, and MC should be shorted, and L should be connected to the one of the inductive load. The other end of the same VV connection should be shorted together, and the interconnected value should be connected to the ammeter, and the other end of the ammeter should be connected back to the V position. And the output of this, the other side of the TPST should be connected to the M, and MC should be shorted. L is connected back to the load. Then we need to perform the delta connection onto the inductive load. This is how the delta connection should be done. Then the other end which is let out, that is the blue, this end. So that end should be connected also to the L, to this part, that is L. Okay, so this is how it completes the loop of your the stator winding. Coming to the rotor, positive supply is connected to the ammeter. The other end of this ammeter should be connected to the field winding, and the field winding is connected back to the negative supply. And similarly, the voltmeter should be connected across the two ends, that is U and V. So here also we are going to conduct the same test as what we preferred. The only the thing is we require the ZPF point. We require one point on the ZPF curve. So let me follow up that procedure. So the circuit will be rigged up as shown, and with the SPST TPST switch both will be in the open stage, open, and the rheostat will be in the cutout position. Switch on the supply. Okay, switch on the supply. Then the SPST and TPST switch both should be closed. Then by varying the dimmer stat, okay, in a clockwise, in the alternator circuit, the alternator field current is now increased slowly. So here make sure that this is how this inductive load is, it should be fully loaded. Okay, it should be kept in a fully loaded position. Okay, now you can see that here the demostat is slowly varied such a at that point, as the power factor of the inductive load value will be very low. So if any one of this wattmeter is going to kick back when you're varying this, if one of the wattmeter is going to kick back, then we have to change the CV connections. Okay, then after that connecting, we have to take that particular wattmeter reading as a negative value. Now by adjusting the dimmer stat, again the field by adjusting the dimmer stat, again we have to vary the rated current should be around the 7 amperes. So it should read around the 7 amperes. Should pass through the load. So only one single reading need to be taken down. So when this ammeter is going to read 7 amperes, the corresponding W1 and W2 should be taken down. So this completes your the ZPF curve, and we have to take down the readings. Okay, so and the remaining the OC and SC test need to be repeated as what we had done in the EMF method and as well as the MMF method. Okay, the same procedure should be carried out. Only the difference is the ZPF test. So the corresponding the field current should be taken down. I is the 7 ampere and corresponding volt should be taken, and W1 and W2 should be taken down, and also from this the power factor value will be calculated. Then the same value can be taken down as what we did for a EMF and MMF method, that is nothing but the armature resistance. So armature resistance is measured here as what we have done. Similarly, we have to the analogy is this is a different way how to solve the voltage regulation by making use of a Portier triangle. So in this case, you can see that this is the location of the ZPF curve. So a ZPF curve can be obtained only by conducting the ZPF test. Okay, zero power factor test. So in this case, IF1 is a field current which is required to produce a voltage E1, which is found by the OCC, and then it is drawn perpendicular to the E1. IF2 is the field current which is required to overcome the armature reactions, and it is equal to that of the PF value, and it is drawn perpendicular to the IA. I into XA, and IF is the net field current which is required to produce the rated voltage at a power factor of a cos phi. So here this is the analytical method which you have to make use of it. That is, we have to find out the E1. So E1 will be equal to square root of V of cos phi plus IARA whole square plus V into sin phi plus or minus I into XL whole square. So once you get this value, we have to find out the corresponding value of the field current. Then only we can solve the percentage regulation, that is nothing but the E naught minus V divided by V into 100. Okay, so this will be the expected graph when you solve for the different values of the power factors. So this is how we can complete the open. Also we have to perform this OC and short circuit test in addition to the ZPF test for this alternator. And percentage regulation at different power factors will be predetermined by making use of this Portier reactance method. Thank you for watching this video.